Okay, in this question, I want to deal with if we're asked to differentiate something like y equals sine cubed 5x squared. Now, we've dealt with if there's a complication in the angle, we follow the rule in our log tables and then we multiply by the derivative of the algebra. We've also dealt with if I put a coefficient in front of the trig, you just take the coefficient down. But this is an added complication in that the trig is to a power. It's sine to the power of 3. So this one is a little bit more complicated. Now, often people do this by using the chain rule, but I find it's far easier to do it by the method I'm about to show you. First of all, I want you to just be aware that sine cubed 5x squared is the same as sine 5x squared to be cubed. Okay, it's the same thing. It's just that when we're dealing with trigonometry, rather than putting the power out here, we tend to put the power in here. So I just want you to be aware of what the sine cubed means. It means the whole thing is to be cubed. Now, I always split this question into 3. The first thing you need to accommodate for is the power. Then you need to try and differentiate the trig, and then you need to differentiate the algebra. So I always tell my students that what we're doing here is PTA, power, trig, algebra. So the first thing I want to differentiate is only the power. First of all, the derivative of y is dy dx. Now, so first thing, I'm only thinking about the power. So this is to the power of 3, which means in my mind, I would think of this as if it was an x to the power of 3. If I had x to the power of 3 and I asked you to differentiate it, you bring the power in front, so it would become 3x, and the power decreases by 1. So it would become 3x to the power of 2. The derivative of x cubed is 3x to the power of 2. Which means that the derivative of sine cubed 5x squared would be, I just treat this, I bring the 3 in front, it will be 3 sine squared 5x squared. So I want you to realize that x to the power of 3, the power comes in front and is 3x squared. This is sine to the power of 3, the power comes in front and is 3 sine squared 5x squared. So I want you to realize that what I've done here is the exact same as what I've done here. And then as far as I'm concerned, I've accommodated for the power. That's my power bit sorted. That's the first step of 3. In order to differentiate the next bit, I'm now only concerned with the trigonometry. I've already dealt with the power, so in my mind I would imagine that the cubed is gone. Obviously in an exam you can't actually eliminate the cubed, but in my mind now, it's as if I'm just differentiating sine 5x squared. And I'm only going to worry about the trig now. The derivative of sine of an angle, well, according to my maths tables, the derivative of sine of an angle is just cos of that angle. So the derivative of sine 5x squared is just cos 5x squared. And I've dealt with the trig. That's my second step. The derivative of sine 5x squared is just cos 5x squared. Once I've dealt with the trig, in my mind I can pretend like the trig is gone. Now I'm just getting the derivative of the algebra. This is the very first thing we looked at. The derivative of algebra, I just bring the power in front. 2 times 5 gives me 10, and the power of x decreases by 1, so it's just 10x to the power of 1. And that's my third thing that I need to differentiate, that's the algebra. So, obviously I shouldn't have actually wiped that out, I was only doing it to explain it. The derivative of sine cubed 5x squared, you first deal only with the power. So you get 3 sine squared 5x squared. Then you deal only with the trig. The derivative of sine of an angle is cos of that angle, so I get cos 5x squared. Then you deal only with the algebra. The derivative of 5x squared is 10x. So that's why I always tell my students that this is PTA. Deal with the power, deal with the trig, and then deal with the algebra. Obviously, I could tidy this one up a little bit. I could multiply the 10x here by 3. 10x by 3 is 30x. So my final answer simplified would be 30x sine squared 5x squared cos 5x squared. That's the derivative of sine cubed 5x squared simplified fully. Now with that in mind, I'm going to give you a few more questions to do here where I want you to differentiate them using the steps power, trig, algebra. Okay, the next thing that I want you to do is differentiate the following. Y equals 3 sine to the power of 4x. Y equals 4 cos to the power of 5 2x squared. Y equals tan cubed 7x squared. Y equals tan to the power of 5 x cubed. In each case, you're going to need to do 3 separate differentiation steps. First of all, the power. Second of all, the trig. Third step is your algebra. So in each case, I want you to work through it and get the derivative in each case. Okay, the first thing I asked you to differentiate here was y equals 3 sine to the power of 4x. Now, first of all, the derivative of y is dy dx. And there's a coefficient in front of the sign, so I'm just going to take down the coefficient. The coefficient there, it has really no effect on the question, but it's still present in my answer. And now I have to get the derivative of sine to the power of 4x. Now, trig, you should realize this is PTA. I know that I have to do power trig algebra because it's trig to a power. Sine to the power of 4, I need to follow 3 different steps here. The first thing that I want to deal with is solely the power. I first want to differentiate something to the power of 4. So I just think in my head, right, well, if I had x to the power of 4, how would I differentiate this? I would bring the power in front and I would decrease the power by 1. So I would end up with 4x to the power of 3. If I had to differentiate x to the power of 4, it would be 4x to the power of 3. So that means I know that if I have to differentiate sine to the power of 4x, it will become 4 sine to the power of 3x. X to the power of 4 becomes 4x to the power of 3. Sine to the power of 4 becomes 4 sine to the power of 3. And I keep the angle. So that is my trig dealt with. That's my power dealt with. So I dealt with the power, and once I've dealt with the power, I now need to deal with the trig. So it's as if I've already dealt with the 3 there, I've taken it down, and I've dealt with the power. So in my mind, I could imagine that it's just gone. And now I just need to deal with the trigonometry. According to page 25 in my maths tables, the derivative of sine x is cos x. I actually have sine x. So the derivative of sine x then just becomes cos x. And that's my trig dealt with. Now, the third thing we always have to do is get the derivative of the algebra. But in this case, the algebra is just x. And the derivative of x is just 1. If I had x to the power of 1, I just bring the 1 in front and it would become x to the power of 0. So the derivative of x is just 1. Which means I could put in a 1 there, but it doesn't really matter. I don't really need to put it in at all. So I started off with 3 sine to the power of 4x, and I've worked out that the derivative is 3 by 4 sine cubed x by cos x by 1. Now to simplify this down, I could, I suppose, multiply the 1 by the 4 by the 3. 3 by 4 is 12, and the 1 doesn't really matter. So I've got 12 sine cubed x cos x. And that's my final answer for the derivative of y equals 3 sine to the power of 4x. In part B here, I asked you to get the derivative of 4 cos to the power of 5 2x squared. So the derivative of y is just dy dx. Now you should identify that this is where we're using PTA, power trig algebra. I know that because it's trig to a power. Cos to the power of 5 tells me there's going to be 3 different steps to this. First of all, there's a coefficient in front of the cos, so as always, I'll just take down the coefficient. It's just a 4, I'll just take down the 4. And now I need to get the derivative of cos to the power of 5 2x squared. So let's just in our mind pretend like we've dealt with the 4, so it's gone. Now I only want to deal with the power. I've cos to the power of 5. So let's just think about what would we do if we had x to the power of 5. The derivative of x to the power of 5, I would bring the 5 in front and I would decrease the power by 1. It would become 5x to the power of 4. So with that in mind, I could say that cos to the power of 5 will just become 5 cos to the power of 4. And the angle will stay the same. So it was cos to the power of 5, it's now 5 cos to the power of 4. And I take down my angle as well. So that is the power dealt with. That's the first step in my PTA. Once I've dealt with the power, the next thing I need to deal with is the trig. And I could pretend as if the 5 is gone now, as if I'm only left the power. I've dealt with the power, so let's pretend it's gone. Now to deal with the trig, I have cos 2x squared. According to page 25 in my maths tables, the derivative of cos of an angle is minus sine of that angle. Which means the derivative of cos 2x squared is minus sine 2x squared. And that is my second step, which is my trig step. Once I've dealt with the trig, I can pretend the trig is gone. And now I need to deal with the third step, which is the algebra. The derivative of 2x squared, I just bring the 2 in front. 2 multiplied by 2 is 4. And I decrease the power of x by 1. So I just get 4x to the power of 1. So that's my third step, which was the algebra. Hence why I'm calling this PTA. Now obviously I shouldn't have actually crossed these out. It's just easier to imagine what's going on. So I had 4 cos to the power of 5 2x squared. That has become 4 by 5 cos to the power of 4 2x squared by minus sine 2x squared by 4x. So obviously we can simplify this a little bit. 4 multiplied by 5 is 20. And then 20 multiplied by 4x is 80x. I could also multiply that by this minus. This is, say, a minus 1. Minus by 80x gives me minus 80x. So in summary, if I multiply 4 by 5 by a minus by 4x, I'll get minus 80x. And then I just have to rewrite out my trig functions. Cos 4 2x squared, so it's cos to the power of 4 2x squared. And then I've already accommodated for that minus, so I can just say now that this is sine 2x squared. And I can't really simplify that any further. In an exam question, it won't tend to end up that messy, but just be aware that while we're practicing it, we need to practice some of these complicated ones so that we're able to do the exam questions when we get to the practical applications. But ultimately, that's your final answer for part B here. In part C here, I asked you to differentiate y equals tan cubed 7x squared. The derivative of y is dy dx. And you should recognize that this is trig to a power. It's tan to the power of 3, which means, again, it's PTA. We first deal with the power, then we deal with the trig, then we deal with the algebra. The power in this case is 3. It's tan to the power of 3. So I would ask myself, how would I differentiate x to the power of 3? If I had an x to the power of 3, I would bring the power in front, and it would be 3x to the power of 2. With that in mind, I can say that tan cubed 7x squared, if I only dealt with the power, would become 3 tan to the power of 2 7x squared. X cubed is 3x squared, tan cubed is 3 tan squared. So that's the power dealt with. And in your mind, you should imagine like the power is completely gone. We're now differentiating tan 7x squared. And according to page 25 in my maths tables, the derivative of tan of an angle is sec squared of that angle, which means tan 7x squared becomes sec squared 7x squared. Now that's my trig step, and now I can pretend as if the trig is gone because I've dealt with it in terms of differentiation. The last thing I need to do now is just differentiate the algebra. The derivative of 7x squared, well, the 2, I just get 2 multiplied by 7 would be 14, and the power of x decreases by 1, so it just becomes x to the power of 1. And that's my third step, that's the algebra. So that's my 3 steps, power, trig, and algebra dealt with. And obviously I should have rewritten this in. Originally I had tan cubed 7x squared. Yeah, so originally I had tan cubed 7x squared. Now I can obviously simplify this a little bit. I could multiply the 3 by the 14x. 3 by 14x gives me 42x. And I can't really do anything. These are 2 different trig functions, so I just have to list them. Tan squared 7x squared, sec squared 7x squared. And that's my final answer for the derivative of tan cubed 7x squared. Okay, so the last one I gave you was y equals tan to the power of 5x squared. Again, it's tan to the power of something. You should realize trig to a power, and it's PTA, power trig algebra. The derivative of y is dy dx. And the first thing I need to accommodate is the power. I have tan to the power of 5. So I ask myself, what would I do if I had x to the power of 5? If I had x to the power of 5, it would just be 5x to the power of 4. Bring the power in front and decrease the power by 1. So I can now say that tan to the power of 5 will become 5 tan to the power of 4, and the angle just tags along. That's my power dealt with, so I could pretend as if the power is gone. And now I just need to deal with the trig, tan of x cubed, or tan of an angle. According to page 25 in my maths tables, the tan of an angle becomes sec squared of that angle. So tan x cubed just becomes sec squared x cubed. And that's my trig dealt with. That's the second step, so I can pretend as if the trig is gone. Now I just need to deal with the algebra. The derivative of x cubed, well, I would bring the power in front and it would become 3x to the power of 2. So that's my third one, that's my algebra. I've dealt with my power, I've dealt with my trig, I've dealt with my algebra. So let me just plug back in. The original question was tan to the power of 5x cubed. Now to simplify this, there's not a lot we can do, but we can multiply 3x squared by the constant 5. 3x squared by 5 is 15x squared. And then I've just got two different trig functions, so I have to just list them out. Tan to the power of 4x cubed, sec squared x cubed. And that's my final answer for the derivative of tan to the power of 5x cubed. Okay, so the next thing I want to talk to you about is how to differentiate exponential functions. According to page 25 in our maths tables, the derivative of e to the x is e to the x. In other words, it stays the same. Nothing actually happens to it. So obviously that means if you had a question where y is equal to e to the x, then the derivative of that, dy dx, would just be, it's the exact same, it just stays as e to the x. But obviously there is a couple of possible complications here. First of all, you could get a coefficient. Supposing I told you y was equal to 3 times e to the x. Well, in this scenario, we're going to deal with coefficients the exact same way as we have been dealing with coefficients. If I asked you to get the derivative of 3e to the x, you just take down the coefficient. It doesn't really affect the question, we just take it down. So the 3, we take down the 3, and then we get the derivative of the other bit. The derivative of e to the x is just e to the x, so it actually just stays the same. So that means that the derivative of 3e to the x is 3e to the x. It doesn't change at all. However, there is a scenario where things will change. In all of those questions, it's always to the power of x, but obviously that power could change. Supposing I asked you to get the derivative of e to the power of x squared. Well, in this case, we have to do two different things. We first need to get the derivative of the exponential and then the derivative of the algebra. Okay, so the derivative of y is dy dx. And the derivative of e to the power of something is e to the power of the same thing. So the derivative of e to the power of x squared is e to the power of x squared. It stays the exact same. Once we've dealt with the exponential, we can pretend in our minds as if the exponential is gone. We could, as if we're just now getting the derivative of x squared. The derivative of x squared, the 2 comes in front, is just 2x to the power of 1. So in other words, the derivative of e to the x squared, you just rewrite it and then you multiply by the derivative of the power. So it stays the exact same and then you multiply by the derivative of the power. That's really what I want to look at for exponentials here. So with that in mind, I want to now give you a few questions and I want you to differentiate them. Okay, so with that in mind, I want you to do these 4 questions. I want you to get the derivative of 3e to the x squared, e to the sine x, 1 over root 2 pi, e to the minus a half x squared, 1 over pi, e to the power of cos 2x. So I want you to pause the video, take these down, and then work through them and then watch my solutions. Okay, the first one I asked you to do was to get the derivative of 3e to the x squared. First of all, the derivative of y is dy dx. Okay, there's a coefficient in front of the exponential, and as always, the coefficient is basically irrelevant, but we have to take it down nonetheless. It's 3 in the original function, it's still 3 in the derivative. Now we need to get the derivative of the exponential, the derivative of e to the power of something. And according to page 25 in my maths tables, the derivative of e to the power of something just stays the exact same. So the derivative of e to the power of x squared is just e to the power of x squared. So now I've dealt with I've dealt with the 3 and I've dealt with the exponential. But now I need to get the derivative of the power. The derivative of x squared is the 2 comes in front and it would be 2x to the power of 1. So my original question there was just 3e to the x squared. The derivative works out as this. Now obviously I could simplify this by multiplying 2x by 3. 2x multiplied by 3 is 6x e to the x squared. And that's my final answer. The derivative of y in this case would give you this. Okay, the second one I asked you to do was to get the derivative of y equals e to the power sine x. The derivative of y is just dy dx. And I have e to the power of something. According to page 25, the derivative of e to the power of something, it just stays the exact same. So e to the power of sine x is just going to become e to the power of sine x. It just stays the exact same. Now I've dealt with the exponential, I can imagine as if the exponential is gone. Now I need to get the derivative of the power. The derivative of sine x, well, I can also read that off my maths tables. In my maths tables, it tells me that if I have sine x, the derivative of sine x is cos x. So I can now use that rule. If I have sine x here, the derivative of sine x is cos x. So there's two steps to that one. We first deal with the exponential, and then we deal with the trig. So the final answer there is just e to the sine x multiplied by cos x. Part C, I've actually taken this one from an exam question. It looks incredibly intimidating, but in fact it's actually very straightforward. So let's just follow the exact same steps. I can do more or less, this is the exact same as part A in this question. The derivative of y is dy dx. And 1 over root 2 pi is a coefficient. That's just a constant. Remember, pi is a number. Pi is just a constant. So 1 over root 2 pi is just a constant. And we know that if you have a constant as a coefficient, we just take it down. It doesn't affect the question. It's there in the original question and it's still there in the derivative. So I just take that down and it has no bearing on the rest of the question. I know, according to my maths tables, that e to the power of something just stays the exact same. So e to the power of minus a half x squared is just e to the power of minus a half x squared. Now that I've dealt with the exponential, I've dealt with the coefficient and I've dealt with the exponential. But I haven't dealt with this power. I now need to get the derivative of the algebra. The derivative of minus a half x squared. Well, if I have a 2 there, if I bring the 2 in front, 2 multiplied by minus a half is minus 1. And then the power of x decreases by 1 and it becomes x to the power of 1. So let's just recap on that one. There was a coefficient, so I just take down the coefficient. There was e to the power of something, so it just stays the exact same as it tells me to do in my log tables. But then I have to get the derivative of the power, or the derivative of the algebra. So minus a half x squared, the derivative of that is minus 1x. Now I could tidy this one up by multiplying the minus 1x by this fraction. If I did that, minus 1x by 1 would be just minus 1x divided by root 2 pi e to the minus a half x squared. And that's as far as I can simplify it, so that's my final answer for the derivative in this case. In part D, I asked you to differentiate y equals 1 over pi e to the cos 2x. So the derivative of y is just dy dx. And again, you should notice that we have a coefficient. We have a constant coefficient, it's 1 over pi. So it has no bearing on the question, but I just need to take it down. It will be part of the derivative. There's a 1 over pi there, there's a 1 over pi there. And now I notice that I have e to the power of something. According to page 25 in the maths tables, e to the power of something just stays the same. It's still e to the power of whatever it was. So e to the power of cos 2x, the derivative of that is just e to the power of cos 2x. And at this stage, you could view this as we've dealt with the constant, it's there, we've dealt with the exponential. But now what remains I still need to deal with. I now need to deal with the derivative of cos 2x. And according to the maths tables, if I have cos of something, the derivative becomes minus sine of the same angle. So the derivative of cos 2x is just minus sine 2x. But remember from your trig that now we've dealt with the trig, I now need to deal with the algebra. I now also multiply by the derivative of the algebra. In this case, I'm going to multiply by the derivative of 2x. The derivative of 2x is 2. Because that's 2x to the power of 1, so the 1 comes in front. 1 multiplied by 2 gives me 2. The x becomes an x to the power of 0, so it's gone. So there was a number of steps to that one. That one's quite tricky. So I'll just rewrite this. I had 1 over pi e to the power of cos 2x. I suppose we could tidy this one up. It's messy enough, but I can tidy it up. Minus by 2 by 1 gives me minus 2. So if I just multiply the 2 by a minus by the top of that fraction, that's minus 2 over pi e to the power of cos 2x multiplied by sine 2x. And that's, I can't really tidy that up any further, so that's your final answer for the derivative. Okay, in this video I want to talk to you about the product rule. Now the product rule is relatively straightforward to use. It's available on page 25 in your maths tables. If you go to page 25 and you go to the right hand side of the page, the very first rule is the product rule. You use the product rule if you have a situation where you're told that y, your function, is equal to u multiplied by v, where u is a term with a variable in it and v is another term with a variable in it. So for example, the question I'm about to do is y equals x squared plus 3 multiplied by x cubed plus 9. In this scenario, I can say, right, well, the first term here is x squared plus 3. It has a variable in it, and I'm multiplying that by another thing that has a variable in it, another expression with a variable, which is x cubed plus 9. If you're multiplying one expression with a variable by another expression with a variable, then you use the product rule. Let me just run through a few examples. Like, for example, if you had y equals 3 by sine x. The sine x has a variable in it, but the 3 is just a constant. So like we've been doing that all along. We don't need to use the product rule. Even though it's 3 multiplied by sine x, we don't need to use the product rule. We can do that much easier. We could use the product rule, but it makes life harder for us. In the maths tables, it tells me that to use the product rule, to get dy dx, the derivative, it's u multiplied by dv dx plus v multiplied by du dx. So what I want to do, all of what I have above that broken line is available in the maths tables. Let's go through an example now. If I give you y equals x squared plus 3 by x cubed plus 9, you should recognize that in order to differentiate this, I need to use the product rule. Because I have an expression with a variable multiplied by another expression with a variable, that means I need to use my product rule. In this case, the first term will be u and the second term will be v. So obviously, if this is y relative to x, so to get the derivative, I need to find dy dx. But I know from my maths tables that in order to find dy dx, I need u, dv dx, and v and du dx. So I need 4 different things. So what I always recommend to students here is that you work all of those things out in your rough work. So before I even worry about getting my actual derivative, I need to figure out what is u. And then I need to figure out what is du dx. Figure out what is v, and then I figure out what is dv dx. If I can find these 4 things, I'll be able to sub into the product rule and I'll be able to find dy dx, the derivative. So u is always the first thing, or the first expression. The first expression I have here is x squared plus 3. Now, on this line I have u relative to x. So if I differentiate this, the derivative of u would be du dx. Okay, I want you to realize that in every question we've done so far, we've had y equals something in terms of x, y relative to x. And in order to get the derivative, we always said that was dy dx. But in this case, I have a u instead of a y, so I'll say the derivative is du dx. The derivative of the right hand side, the derivative of x squared, the 2 just comes in front and it becomes 2x to the power of 1. Well, the derivative of 3 is just 0. So now I have u and I have du dx. Now I need to work out what v is. According to the maths tables, v is the second expression in your term. The second expression I have here is x cubed plus 3. If I have v relative to x and I differentiate, I'm going to work out dv dx. So I just get the derivative of the right hand side. If you have x cubed, the 3 comes in front and the power decreases by 1. So I get 3x squared. Well, the derivative of 9 is just 0. So now I have u, du dx, v and dv dx. I can just sub in and I can find dy dx. So ultimately the question was, get the derivative of y if y equals this. So I can now say that the derivative dy dx is u, which in this case is x squared plus 3, times dv dx, which in this case is 3x squared, plus v, which in this case is x cubed plus 9, times du dx, which in this case is just 2x. So it's u by dv dx plus v by du dx. And that's your derivative. Now, in the leaving cert, when these questions come up, realistically, it's not going to be algebra, it's going to be exponentials or sine, it's going to be trigonometry, or it's going to be exponentials or something along those lines. So usually, we won't have just a whole load of algebra to multiply out. So as we go through this video, I'm not too concerned with simplifying this down. Obviously, we could multiply this out and simplify it down, but for the moment, when we're practicing the product rule, I think it's a safer bet. I just want you to be able to get to this stage. If you're just able to get to the point where you can say dy dx equals this, then I'm happy enough. When we get to more advanced questions, at that stage we need to simplify them down. If you'd see in all the exam questions, in the tutorials I have for the exam questions, usually we do have to simplify them down. I just want you to be aware that there is an alternative way of doing that question. When I give you y equals x squared plus 3yx cubed plus 9, that's just double brackets. You could just multiply that out and turn it into an algebraic expression with no brackets in it. You could have just multiplied it out. When you've multiplied it out, you then get the derivative. But for just going through this example, I wanted to do an easy one. We could say dy dx is equal to this. So to practice our product rule, I'm going to give you 6 questions. I want you to differentiate x squared e to the x. That's x squared multiplied by e to the x. So that means that x squared will be your u, e to the x will be your v. You can find the u dx, you can find the v dx, and then you can sub in to the formula in our maths tables. The second one is x cubed by 7 cos x. The third one is e sine x by cos x squared. That's x squared. It's not a cos squared, so it's not your PTA. It's just cos x squared. So be aware that it's not the cos to be squared, it's just the x to be squared. The fourth one is t squared e to the t. So since I'm using a t rather than an x, rather than calling your derivative dy dx, you're just going to call it dy dt. Because instead of an x, I'm using a t. The fifth one is 3x squared by e to the minus a half x squared. And the sixth one is cos 3x by e to the cos 2x. In each case, you should write out u equals this, then get du dx. V equals this, then get dv dx. Then just sub into the formula u by dv dx plus v by du dx. And I'm not too concerned about you multiplying these out. For the moment, before we start looking at practical questions, it's just important you can actually get to your derivative. So I want you to pause the video now, take all of these down and try them, and then watch my solutions on it. Okay, so the first one I asked you to do here was y equals x squared by e to the x. This is clearly product rule. Obviously in the leave insert it won't tell you if it's product rule or not. But I know this is product rule because it's algebra multiplied by an exponential. I have to use, there are 2 separate rules that exist on the table on page 25 in the maths tables. There's a rule for differentiating algebra, there's a rule for differentiating exponentials. If I'm multiplying 2 of the rules together, I have to use the product rule. In which case I'm going to start by working out what is u, du dx, v and dv dx. U will be the first thing, which in this case is x squared. And the derivative of x squared, I just bring the 2 in front and I get 2x to the power of 1. Then v is e to the x. And according to page 25 in the maths tables, the derivative of e to the power of an x just stays the exact same. It's just dv dx in that case will be e to the x. So once I know all 4 of these, I can just sub in. The maths tables tells me that the derivative when using the product rule is u multiplied by dv dx plus v multiplied by du dx. In this case, u is x squared and dv dx is e to the x. V is 2x and du dx is e to the x. We could go further with that and factorize out the e to the x, but in this video I'm just concerned with you being able to actually get the derivative. So I'm not too worried about simplifying that. Let's just leave our answers in this form. Okay, the second one was x cubed multiplied by 7 cos x. There's a rule in the log tables that allows me to differentiate algebra. It's the first rule. There's also a rule that allows me to differentiate cos x. I've got one of the rules and I'm multiplying it by another one. Algebra by trig. 2 separate rules means I have to use the product rule. In this case, u is x cubed, so the derivative du dx, the 3 comes in front and the power decreases by 1, it's 3x squared. V is 7 cos x. 7 is just a coefficient, so it's more or less irrelevant, but I do just take it down and it's there in the derivative as well. And according to the maths tables, the derivative of cos x is minus sine x. So dv dx is 7 by minus sine x, or in other words, minus 7 sine x. Now I just sub in, u is x cubed, dv dx is minus 7 sine x. V is 7 cos x and du dx is 3x squared. Now minus 7 by x cubed is just minus 7x cubed sine x. 3x squared by 7 is 21x squared cos x. Now we could go further there and we could factorize out a 7x squared, but for the moment let's just leave it like that. We'll consider that to be our final answer. Okay, the third one I asked you to do was y equals 3 sine x cos x squared. Again, this one is product rule because it's two separate rules. There's a rule in the log tables that allows me to get the derivative of sine of an angle. There's also a rule in the log tables that allows me to get the derivative of cos of an angle. They're two separate rules from the log tables, and I'm multiplying them by each other. That tells me it's product rule. So the first one I'm going to call u. U in this case is 3 sine x. To get the derivative of 3 sine x, I want to get the u dx. There's a coefficient of 3, and as always, the coefficient is basically irrelevant. It's there in the original question, it's there in the derivative. So just take down the 3, and then according to the maths tables, the derivative of sine of an angle is just cos of that angle. So sine x becomes cos x, and du dx is just 3 cos x. V works out in this case as the second one, it's cos x squared. So according to the maths tables, the derivative of cos of an angle is minus sine of that angle. So cos x squared becomes minus sine x squared. But I then must multiply by the derivative of the algebra. Or in other words, multiply by the derivative of x squared. So I bring the 2 in front, and the derivative of x squared is just 2x. So now that I have all four of these, I can sub into the formula in my log tables. dy dx is u by dv dx plus v by du dx. In this case, u is 3 sine x. dv dx, I've multiplied the 2x by the minus, and I've written it as minus 2x sine x squared. V in this case is cos x squared, and du dx is 3 cos x. Now I want you to notice that the sine x here and the sine x squared here are not like terms. That's sine of the angle x, that's sine of the angle x squared. They're different angles, they're not like terms. It's like multiplying x and y, they're not like terms, you cannot multiply them by each other. I can multiply the minus 2x by the 3 and write that as minus 6x. And then I just have to write it as sine x squared. They're different angles. That's the sine of the angle x, that's the sine of the angle x squared. So they're different angles means they're like, it's like apples and oranges. You can't multiply them by each other. Same thing goes here. I just put the 3 in front and I have cos of x squared by the cos of x. And that's as far as I can simplify that one, so that's our final answer. And now, if they asked you, you could factorize out a common factor here of 3, but in this case, let's just leave it like that. Okay, for the fourth part here, I asked you to get the derivative of t squared by e to the t. Again, there's two separate bits to this. T squared is algebra, it's like having an x squared. E to the power of t is an exponential. Two separate rules on page 25 in my maths tables, and I'm multiplying them by each other. That means I'm using the product rule. So in this case, u is t squared, and if I have u relative to t, which means when I differentiate u, I get du dt. If u is equal to t squared, I can say that du dt, the 2 comes in front, and I just get 2t. And then v in this case is e to the power of t. And to get the derivative in this case, the derivative of v would be dv dt. And according to the maths tables, if you have e to the power of something, it just stays the exact same. E to the power t becomes e to the power t. And now I need to sub into my formula. I need to find dy dt. And according to the product rule, dy dt will be u by dv dt plus v by du dt. In this case, u is t squared, dv dt is e to the t. V is 2t and du dt is e to the t. I could simplify further by factorizing out the common term, but in this case that's sufficient. We found our derivative, so let's consider that our final answer. The fifth one I asked you to differentiate was 3x squared e to the minus a half x squared. Once again, you should notice that first of all I have algebra, and second of all I have an exponential. Two separate rules that exist on page 25 in the maths tables. One of them is for differentiating algebra, one of them is for differentiating exponentials. If I'm multiplying the two rules by each other, that means it's product rule. In this case, my u is 3x squared. And to get the derivative of 3x squared, I just bring the 2 in front. 2 multiplied by 3 is 6. and the power of x decreases by 1 and it becomes x to the power of 1. V is e to the minus a half x squared. According to page 25 in the maths tables, the derivative of an exponential 3 to the power of e to the power of something just stays the same. E to the power minus a half x squared just stays the exact same. Once I've differentiated the exponential, I can pretend as if the exponential is gone, and now I have to get the derivative of what remains, or in other words, the derivative of the algebra. The derivative of minus a half x to the power of 2, the 2 comes in front, and 2 multiplied by minus a half gives me minus 1. And the power of x decreases by 1, and it becomes minus 1x to the power of 1. So it just stays the exact same, and then I multiply by minus 1x. So dv dx just works out as that. And now that I know du dx v and dv dx, I can just sub in and I can get the derivative, dy dx. So it's u in this case is 3x squared, by dv dx is minus 1x by e to the power of this, plus v, which is e to the power of this, by du dx, which is 6x. All I've done here is I can multiply the minus 1x by the 3x squared. Minus 1x by 3x squared is minus 3x to the power of 3. E to the power of that, and then I've put the 6x in front, and it's just 6x by e to the power of that. Now let's just leave our answer there. Okay, the final one I asked you to do here was quite complicated. Y equals cos 3x by e to the cos 2x. First of all, once again, I'm multiplying trig by an exponential. There's a separate rules in differentiation for differentiating trig and for differentiating exponentials. So if you're multiplying them by each other, you're using the product rule. U in this case is cos 3x. And the maths tables tells me that the derivative of cos of an angle is minus sine of that angle. So cos 3x becomes minus sine 3x. Then I multiply by the derivative of the algebra. The derivative of 3x is just 3. My v in this case is e to the cos 2x. And according to the maths tables, the derivative of e to the power of something just stays the same. So I end up with e to the cos 2x. But I then have to multiply by the derivative of the power. So I have to get the derivative of cos 2x. And according to the maths tables, the derivative of cos of an angle is minus sine of that angle. So cos 2x becomes minus sine 2x. But then I need to multiply by the derivative of the algebra. So I need to multiply by the derivative of 2x, which is 2. If you're struggling with the process there, just think of it as, first thing I deal with is the exponential. The derivative of e to the power of something, it just stays the same. It's e to the power of the same thing. Then I've dealt with the exponential, so it's gone. Now I have to deal with the derivative of cos to the cos of an angle, just becomes minus sine of that angle. Now I've dealt with the trigonometry, so the trigonometry is gone. Now I have to get the derivative of 2x, which is the algebra, and the derivative of 2x is just 2. Once I've dealt with that, I've dealt with everything, and then I know that that's my entire derivative. So that's the process for differentiating e to the cos 2x. So it works out quite complicated, but it's important that you follow each step. Once I have these four, I can just sub in u dv dx plus v du dx. U is cos 3x. dv dx is, I've multiplied the 2 by the minus and I got minus 2. I've put the sine 2x first, so I get minus 2 sine 2x e to the cos 2x. I want you to be aware there that it doesn't really matter what order I have them in. Like if you had left it like that, technically it's still right. I'm just trying to make it a little bit neater, but to be honest, you wouldn't lose marks either way. Then the v in this case is e to the cos 2x, while the u dx is minus 3 sine 3x. So all I did here was I put the minus 2 in the front and then listed out all the rest of the terms. Minus 2 cos 3x sine 2x e to the cos 2x. And here as well, I just brought the minus 3 in front. I have minus 3 sine 3x e to the cos 2x. Now, if you're comfortable with this video, you're in a really good place in terms of your product rule. If you're not comfortable with the video, just let me know or send me an email and I'll try to clarify it for you and I'll try and give you a few different examples.